This is a circuit board out of a record deck from the 80s, made by a company called Logic. The deck was a DM101. This board controls the turntable motor, which is a synchronous motor. Now, the idea of a synchronous motor is that the speed of the motor is basically governed by the frequency of the AC supplying it. The sticker on the back of the motor says 110 volts at 50 or 60 hertz for the two different record speeds. The way the board works is the mains comes in here and it goes straight into a bridge rectifier. I think it goes through a resistor and a fuse first. Two smoothing capacitors are connected in series, and the center point of the two capacitors is ground, which is where I put this hook, which is goes to my multimeter. Then the 150 volts goes through. There's a plus 150 volts on that one and minus 150 volts on that one. These are 15k high wattage resistors. Then on the output of those there's a pair of Zeners there, and there's another pair there that bring this thing down to plus or minus 15 volts. What I found on this board was the plus 15 was down to about plus 9, which was causing a big voltage drop on that resistor. And where those two smoothing capacitors normally would have 150 volts across both of them, one had about 90 volts on it and the other one had about 200, so the whole thing had become unbalanced. I tracked the fault down to this 741 op amp, which seemed to be dragging down the supply. There was also a faulty transistor there. Now this big clump of transistors over here, these two generate an additional sort of stabilized plus or minus 15 volts for the 741 op amp, and then there's 4 more that control the motor. There's an op amp there which seems to be doing something clever. There's also a flip-flop chip there, and the flip-flop chip is basically hooked up to these buttons which select the different speeds. And this big chip here is an analog switch which is connected to the flip-flops, and these LEDs, there's 2 LEDs, show you which record speed setting you've got selected, are also controlled by the flip-flop. After I've refitted the chip, the power supply was now nicely balanced at plus or minus 15 volts, and it didn't stink of burning any longer. So what I'll do, I'll show you some voltages on it, because you might have one of these that doesn't work and not sure what to expect. I'll start off with the dangerous bit. So if we look at the black capacitors, the smoothing capacitors, on this point here we've got the meter set to 200 volts DC, because we're after the rectifier. So we've got 156 plus 156 volts on that capacitor, and on this other capacitor we got minus 156 volts. Now previously, when it was faulty, this capacitor had about 90 volts on it and this one had about 200, so the whole thing was completely out of whack. Then if I look on the output of these big droppers, the droppers go into as a pair of Zeners. I now switch. That one's got 15.2, and that one's got 14.9, so they're pretty accurate. There's also two transistors here that are also providing a Zener clamped voltage based on the voltage at the other end going into the motor. So this 741 op amp, at that end we got 14.2 volts, and on this end we've got plus 14.5. Then the only way to test it, because I haven't got the motor, is to look at the AC voltage that would be normally going to the motor. So we now put the meter on 200 volts AC setting, where the motor is 110 volts, which comes off this 0 point of these two capacitors. So remember there's 150 volts on each one. So this connector here would go to the motor. The turntable is off at the moment, so we've got no voltage. If I push the button there, we're getting 93.3 volts with that one, and that one is 71.4. So these are the two different motor speed settings I don't know whether these voltages are correct. If I switch the turntable off, the voltage drops down to 0. I'm kind of assuming this board works, but the owner of the board will have to put it back in his turntable and see what happens.